Yo, what is good, dev guys? Welcome back. In this video, I want to move a little bit more forward with the rest of this code. Like I said, this is going to take 3 to 5 videos because it is a ton of code that we have to write. So let's go ahead and navigate to this gameplay ability.h and let's do some of these functions over here because this is a little bit better chunk that we can take a bite out of here and actually get these all done. And then we'll try to get some more of them done inside the ability system component. But let's see what happens here with these functions inside of this ability here. So I am going to Alt Insert and implement all of these puppies. Starting with the get current montage for mesh. Let's go ahead and I don't even think this is in the custom code. I don't think it's in the custom code. So I'm going to just copy all of these functions here. Control X, and I want to go to the bottom. That way we're not getting in between existing Lyra code. So I'm going to do a hashtag read. We'll call this custom code. And I'm going to paste all of my stuff inside of there. And starting with the get current montage for mesh function, we are constructing a local F ability mesh montage struct here, calling that ability mesh montage. And then what we're doing here is saying if we find the ability mesh montage for this mesh and we're using this as an output parameter. So what happens with output parameters, if you guys don't know, is you give it a variable and the output, this function will actually fill that variable with data. That's how the out parameters work. So yeah, if this function returns true, we will return the ability mesh montage.montage here. And if not, we'll just return null pointer. Next, on the set current montage for mesh, we want to ensure that this is instantiated, and this is true if it's instance, and it's always true for blueprints. Then we're making another one of those local variables of the F ability mesh montage, and we're populating that with this find ability mesh montage function here and putting this in as the output parameter. And then if this function returns true, we go ahead and say that this ability mesh montage is equal to the incoming montage here. Else we set this T array of this member variable that we have on the class, the current ability mesh montages. We add an item to it and we add this F ability mesh montage and we give it the mesh and we give it the current montage. So if it doesn't exist, add it to our T array. If it does, go ahead and set the montage on it to this montage. Next, what we want to do inside of this find ability mesh montage is the function that's getting used here. For each of the current ability mesh montages, that's why we're adding this. You're probably wondering why are we adding this to this array here, because this array is what we're using inside of this function to iterate over. So for each of these here, and we're checking if the mesh on the montage data here on this F ability, I guess I should call it on this struct to say it's shorter. The mesh on this struct here, that's the mesh property on this struct is equal to the mesh coming into this function call. If those two things are equal, then we set the montage here, which is an output parameter, equal to the mesh montage. So, and then we return true. If not, we return false. So next, we are doing the montage jumps to section for mesh, and we're checking the current actor info. And we have this local variable to an ability system component, which we're casting to our Lyra ability system component using this get ability system component from actor info check. This just returns a regular U ability system component. So we're casting to ours using the one that gets returned from the actor info. And then here we're saying ability system component is animating any ability for mesh. We pass in this ability, and you can see here that this member is inaccessible, so we need to make this public. So let's make these public, and now you'll see that going away. So now we're checking this Boolean is animating ability for any mesh. Basically, is this ability animating any montages for any mesh? And if that's true, we go ahead and say ability system component, current montage jump to section for mesh. This is the function on our ability system component that we wrote in the last video. We pass it the mesh and we pass it the section name. Next, we got this montage set next section for mesh. I'm gonna just format this. And we're also checking the current actor info. Then we're getting our ability system component by casting using the one from the actor info. And if we are animating an ability for this mesh on this ability, we go ahead and say current montage set next section name for mesh. We give it the in mesh, the from section name, and the to section name. And this is also that function that we called or that we created on our own Lyra ability system component class. So these functions, all of them are just basically wrapping the C++ functions that we wrote in the ability system component so that they're accessible from the gameplay ability. So here we're checking that current info again. We're casting this current info, a current actor info ability system component to our ability system component. I don't know why I did it like this here and like this here. Actually makes no sense, but we're going to go with it. They both work. Here we're checking if the ability system component is not equal to null pointer. I left a comment saying we should only stop the current montage if we are animating the ability. So make sure that this ability is animating some montage for any mesh. If that returns true, then we want to call current montage stop for mesh and pass in the mesh and give it the override blend out time, both coming from the blueprint callable parameters. And then this final function, montage stop for all meshes. And we are checking that current actor info and then getting a pointer to our ability system component by casting using that current actor info's ability system component, checking if the ability system component is not equal to null pointer, as well as checking if this ability is animating any montages on any mesh. And then we call in ability system component stop all current montages and just giving it the override blend out time. So the reason I wanted to do that one first is one, so I didn't forget to get it done, and two, because it's a lot simpler and a lot more straightforward to get complete. We can actually close down the gameplay ability. We're actually done with it, and close that as well. And let's knock out some of the functions on this class that we haven't. So we got about 4, 6, 8, 10, 11. I don't think I'll do this. This one won't be necessary right now. We'll do that later. So let's do these 10 functions and then we'll jump into another video. Okay, so those implemented, I'm going to cut them and make sure that they're inside the region just to make sure, double checking myself here. Of course, let's get that formatting the way I prefer it. I know we got a lot of input parameters here, so. Okay, so starting with this get local anim montage info from mesh, what we want to do is just iterate over the member variable, the local anim montage info from mesh's member variable. And for each of these, we want to check if the mesh on the iteration that we're on is equal to the mesh that we passed in. If so, we want to return that montage info. But if we iterate through all of these here and nothing is equal, we'll come down here and construct one and add it to the array and then return the last element that we just added. Same thing for the replicated version. It's just using the replicated struct. This next function on predictive montage rejected for mesh. This is that callback function that will be bound to the delegate whenever our prediction key is rejected. So this will only fire if something is wrong. So basically here we got this static const float and we call this montage prediction reject fade time. And what we're doing here is if something was rejected on the client, we will be playing it. But if the server rejects it, we need to kind of make it a smooth transition from where we are to where the server is. Because like I said, the client predictively does all of this before the server. And if the server rejects anything, we don't want the client to just like snap back and the players feel like there's a lot of lag or something. We want them to kind of smoothly go back to where they're supposed to be. So this next function, this anim montage update replicated data for mesh. This is just wrapping another function here. So this is telling me that it can convert fgame playability rep anim montage for mesh to parameter of type use skeletal mesh. And that's because this is an overload function that I didn't actually write here. So we need to go back here, and this function is basically similar to this one here, but instead of taking in a mesh, it takes in the fgame playability rep anim montage for mesh. So we don't want it to be inline. We actually want it to be right underneath this function call here. And let me fix the formatting. So this function basically will call this function passing in a, and we're basically going to construct a replicated struct of that fgame playability rep anim montage for mesh. We're going to construct one of those using this mesh here, and that's going to be the output parameter that gets passed to this function here. And then in this function is where we're doing the bulk of the work. And this is one of the longer functions here. We got a couple of long functions for this right here. So in this anim montage update replicated data from mesh, that's taken in the struct here, the replicated struct. The first thing we want to do is go ahead and get the anim instance using the select style code, and also go ahead and create a local anim montage info using that local anim montage for mesh struct that we have. And we want to call get local anim montage for mesh and give it the out rep, the mesh that's on this passed in variable. So what we're checking now is if the anim instance and the montage that's on this local montage info is valid, we want to go ahead and set the anim montage on this replicated output parameter to this anim montage, this local version of it here. Then we want to compress some flags. So constable be is stopped is equal to whether or not the anim instance is stopped. And the anim instance that we're passing in is the one that's off of the local output parameter that gets passed in here. And actually it's from this constructed local variable that comes from what gets passed in here. I'm sorry. So if this is false, we want to go ahead and update the play rate, position, and blend time of the replicated montage info with the anim instance with the data from the anim instance's functions, get play rate, get position, get blend time, using that local montage's info's anim montage. So this is just one, like it says, it's copying the local data to the replicated data. Now we're checking if this is stopped is not equal to this be stopped. If that's true, it says here we want to set this prior to call and update should tick. So we should start ticking if we're playing a montage. So here we go ahead and set is stopped equal to be stopped. And then we check and see if our avatar actor is not equal to null pointer, and then we go ahead and force a net update. This is, like I said, is like refreshing a browser. And then we should update should tick right here. Going down, we want to replicate the next section ID to keep everything in sync. And we actually want to replicate the next section ID +1 on a byte and put the index none in there. Now this is a code that's, like I said, written inside of that shooter class. Whoever wrote that, super smart guy, crazy brain. Don't even know where he got most of this from. So here we're taking this constant current section ID and we're populating it with the anim montage get section index from position. And remember, this is a function that's on the anim montage class, and we pass it the replicated position that we just filled up here with this get position local data. So we grab that from the local data or from the replicated data. And if that current section ID is not equal to index none, we go ahead and make another constant 32. This is the next section ID, and this is equal to the anim instance function called get next section ID. And we pass it the anim montage from the local montage info and the current section ID that we just constructed up here. And then now if that section ID is greater than 256 minus 1, then we send in an error here out to the, send an error out here to the log that lets us know what's going on, something's wrong. And this error, let me make my screen full. This error is a formatted F string, and then we ensure that the next section ID is less than 256 minus 1. And now we're moving on to go ahead and casting our next section ID to uint 8 and saying that it's the next section ID plus 1, and that's what we're populating inside of here. Else we want to go ahead and say our next section ID is equal to 0. And that is that function there. This next function, update forced play flags for mesh. It's pretty simple. Here we construct the struct for our local anim montage info. Call that anim montage info, and we want to grab that local anim montage info for mesh, and we want to give it the mesh that's on this parameter here. And then we want to fill that parameter's play instance ID with the local play instance ID from the one that we just constructed here. Okay, so this function is going to be long because this is the replicated function that gets sent back to clients whenever we change the replicated data or the data that needs to be sent back to the other client. Here, there's a CVAR. I didn't actually put this on the top of the CPP class. So let's go ahead and get that. I'm gonna go up to the top of my class and I'm gonna paste this static tauto console variable, and we gotta give it a type float. And then this is the name of the variable so that we can use it inside the class. And then here we set the name to, and this is the name that you would type into the console. So it's Genesis, replay, montage, error, threshold. This Genesis could be whatever you want. This dot replay. It really, this is just the name that you will remember to type in to change the tolerance level of when the montage playback position is corrected. So the default value, after you put a comma here, the default value is 0.5 of a second. And then the help text, this is the tolerance level when the montage playback position correction occurs and replays. So copy that. And then we should be good. That error should disappear here. So here we are. So we're iterating over all of the replicated animation structs here, the F gameplay ability rep anim montage for mesh struct. We're iterating over all of those. And for each of them, we want to go ahead and get some, construct some local data. Now we want to get a pointer to the world that we're in and check if the new rep montage for mesh, if it has a skip rate Boolean set to true. Now, if that is true, we want to go ahead and set the replicated play rate to 1. Now, this const bool b is playing replay. This is if the world itself is kind of re-watching something that already happened, because in multiplayer games you are playing behind the server, and this is coming from you as another client. So the client themselves, they're predicting everything and it looks like they're doing everything in real time, but to another client, they're seeing all that stuff in a replay of all the things that are happening. So that's what this Boolean is. And now we got this constant float that we say our montage rep position error threshold is equal to if we're playing a replay. If that's true, we want to go ahead and get the value on the thread of this CVAR. And if not, we set it to 0.1. Now we're getting that anim instance pointer by using the select style code here. And if that anim instance is equal to null pointer, or if we're not ready to replicate a montage for mesh, we want to say that this pending montage rep is equal to true and then return out of this function. Else we go ahead and say pending montage rep is equal to false. And remember, this is the member variable in our class that is helping us toggle on and off whether or not we're replicating things to other clients. So if the ability actor info is the owning actor of this ability, if this guy is not locally controlled, so if this is the server version of this ability's owner, we got this static const CVAR, and this is this type of code that is kind of confusing here. Classes like iconsole manager, this looks like an interface here, And we're saying find T console variable data int, and it's looking for the net.montage.debug. This is a Unreal CVAR. So we're looking for the CVAR that actually comes out of this. And then we're going ahead and saying console bool debug montage is equal to this CVAR being active, and the value of it is equal to 1. So if this Boolean is true, we'll go ahead and log some stuff here. If this iterations and a montage is valid, we want to set a new montage to play. So we construct this uint8 replicated play bit. That's that play instance ID off of the current iterations rep montage info. Then we want to go ahead and check if that and a montage is not equal to the montage from that current iteration. We're checking that local one from up above against the current iterations and a montage, or if the local's instance ID is not equal to this replicated play bit. If those are not equal, then we want to go ahead and set the play instance ID of this local version to the replicated play bit. And then we want to call play montage for simulated for mesh. And this basically says that we're not updated on the local side of things. So we need to go ahead and update the montage mesh. We need to update the anim montage and the play rate for the simulated meshes. Then we go and check and see if that local anim montage is equal to null pointer. And we go ahead and log this warning. So once again, what we're doing is just making sure that the local side is the same as the replicated side. And then if it's not equal, we go ahead and set the local's animation montage play rate to the value of this iteration's play rate here on the replicated side. Now we got this const bool b is stopped. This is equal to whether or not the local montage is stopped, and the replicated stopped is equal to a static cast to a bool of this uint8, I believe, of the replicated montage info is stopped. So if the replicated is stopped and the local is not stopped, we need to go ahead and call current montage stop for mesh, passing in the mesh from the replicated iteration and the montage blend time from the replicated iteration as well. Else, if the replicated montage's skip position correction is basically, if it's a uint8, it's basically like a Boolean. So if this is not true or not valid, we'll go ahead and get this constant int32 of the replicated section ID. We'll grab that from the local montage infos and a montage, and we'll call get section index from position using that replicated montage's iterations position. And then we got the next section ID. This is equal to a cast to int32, and we want to use that replicated montage info's next section ID -1. And you see here in the to do here, I said, why do we subtract 1? I still don't know. So now we're checking if that rep section ID is not equal to index_none, so -1. If that's true, we go ahead and make this next section ID int32, and we want to set that to the montage get next section on the anim instance using that local anim montage, but the replicated section ID. And then we're checking if the next section ID is not equal to the rep next section ID. And we'll go ahead and queue that up and synchronize that as well. Let me show you guys the whole thing there. We just say that the anim instance montage set next section, and we want to give it the local anim montage section name with using that rep section ID. Then we want to give it the next section, which is the local anim montage get section name using that rep next section ID. So this is the from section, this is the to section, and then this is the montage here, the anim local. So basically, like I said, we're syncing that local data with the replicated data. Back over here, make sure we haven't reached that update too late and that the client hasn't already jumped to another section. So this is just making sure that we don't give that perceived lag or that perceived rubber banding. This const int32 current section ID, We set this equal to the local montage infos and a montage get section index from position. And we go ahead and give it the montage get position of that local montage infos and a montage here. And here we check if that current section ID, which we made here, is not equal to that rep section ID, which we made up here. And the current section ID is not equal to the rep next section ID. If we get inside of here, we see the comment says client is in the wrong section, teleport him to the beginning of the right section. We go ahead and get this const float, the section start time. We want to grab the local montage infos and a montage, get anim composite section using the replicated section ID. And we want to get the time from that. And then we want to say anim instance montage set position and set that local montage's anim montage to the position of this section start time. Here the comment says we want to update the position. If the error is too great, jump to a replicated position. So here we got the current position float, which is equal to this anim instance montage get position from using the local anim montage. And then we got the current section ID that's using the anim montage on the local montage info as well. And we're going ahead and calling get section index from position, and we're giving it that current position. The delta position is the subtractive of this rep montage's position minus that current position. Comments say here, we only check the threshold if we are located in the same section. Different sections require a bit more work as we could be jumping around the timeline. But we only want to make sure that we're close to the section that we're trying to jump to. So here we got if the current section ID is equal to the rep section ID and the absolute value of this delta position is greater than that CVAR that we set, the montage rep position error threshold, which is defaulted to half a second, and the new rep montage info for mesh is stopped, basically is equal to 0. So if this is false, we want to go ahead and fast forward to the server position on the client. So we make this struct here, this fanim montage instance, and then we want to say get active instance for montage using the anim instance. And we want to give it that rep montage infos and a montage. To see here, the comment says stop trigger notifies if we're going backwards in time because we've already triggered them. So this is basically stopping it from re-triggering those anim notifies here. And we just got this const float, that's the delta time, is equal to whether or not this value coming here, the play rate, is not equal to 0 or it's not nearly 0. And if that's the case, delta position divided by the play rate is the value of delta time. If not, it's 0. And then we're saying if delta time is greater than or equal to 0, we're saying montage instance update the weight. So these are functions that I have no idea what they're doing, but that's what is in the code. And montage instance handle events, taking in that current position, the replicated montage position, and whatever this branching point marker is, a null pointer. And then we call anim instance trigger anim notifies at the delta time. And then the last call is this anim montage set position. And we want to set the local anim montage to the position of the replicated montage info. Next we have is ready for replicated montage for mesh. This is a virtual function, so children might want to override this, but by default we're going to return true. We got another little long function for the server setting the next section of the montage. So in this implementation, we want to just go ahead and grab an anim instance pointer using our select style code here. We can construct the local anim montage for mesh struct here by calling get local anim montage info for mesh, passing in the mesh in this function call. Then if we have an anim instance that's valid, we want to go ahead and cache the current anim montage by getting the montage off of that local montage info that we created up here. And if that client anim montage, which comes in through here, if these two things are equal, then we want to set the next section name on this anim instance to the section name that's coming in through this function from the from. The to is the next section name coming in through this function. And then the montage is the current anim montage. And then we want to correct the position if we're in an invalid section. So go ahead and make this current position constant float and getting the position, filling that with the position of the current anim montage. Then we got the section ID, which we're getting the section index from the position. And then the section name, we're getting the section name from the section ID. It's like a daisy chain there. And then we have this client section ID, which is the client side of this. So we get the montage section index from position on the client's position. And we also go ahead and get just so you know, the client position comes in from the function call. And then we grab the montage section name from the client section ID. And we check if that current section name is not equal to the client section name, or if the current section name is not equal to the section name. Let's go ahead and say anim instance montage set position and say current montage for the montage that we're on, and the position is the client's position. Because remember, we are predictively doing this. So we want the server to be in sync with where the client is. So if the server is not in sync, we'll jump to where the client is. This I foresee having some hacking problems. Maybe people will do some things to their animations, but I gotta look deeper into that. We call that is owner active authoritative. And if that's the case, we want to call that function we did up top, the update replicated data from mesh, and pass in the mesh here. And for this validate, we just want to return true. And pretty much for all of these validates, we want to return true. But you can do like extra checks inside of these validate functions if you wanted to. Like how I was saying, people could probably tweak their play rate. So maybe check the play rate wasn't changed. So for this next function, we want to go ahead and get the pointer to our anim instance by using that inline select style code. Go ahead and make a local anim montage for mesh struct here. And if we got a valid anim instance, we want to get that current montage. And if that is equal to the client montage that is getting passed into this function, we want to go ahead and jump to the next section using the section name that gets passed into this function on the current montage. And then we'll update the replicated version for everyone else by calling update replicated data from mesh, as long as we are the authoritative actor here. The next function, pretty similar. It's just doing the same things over and over, but different, calling the different anim instance functions. So we're getting that anim instance pointer using that select style code. Then we're getting that local anim montage struct there by calling this function here. And if we have a valid anim instance, then, we're going ahead and grabbing that current montage. If those are equal, we'll go ahead and set the play rate on this anim montage on the local info and pass in the in play rate here. And if the owner actor is authoritative, we'll go ahead and update the replicated data for the mesh. And here we'll return true. And as I said, this function, we can just add a to do. Okay, yeah, so we basically will implement this if it's needed for an ability. And pretty much that's all I wanted to cover in this video. In the next video, we're going to actually write the task that all of this code was written for, so that we can finally animate this first person grenade toss. So if you guys are ready for that, I'll see you in the next video. Peace.